Hello students, we are discussing the calculus part of mathematics for high school physics. In this calculus part, in the last class, we tried to understand what derivative means, what differentiation means. Let's quickly revisit what we discussed about derivative. We said the derivative is all about, differentiation is all about rate of change. Let's look at the meanings of rate of change. Rate of change is the ratio of change in y to change in x. Delta y by delta x is rate of change in y with respect to x in a given interval of x, in the interval say from x1 to x2, in the given interval of x. Okay, I can say in the given interval of x. This is what we discussed. We also calculated delta y by delta x for different functions. We took an intervals, x varies from x is equal to 1 to x is equal to 2. Then we calculated delta y by delta x. And what is dy by dx? Dy by dx or limit delta x tends to 0, delta y by delta x means what? This is rate of change in y with respect to x at a given value of x. At a given value of x, rate of change in y with respect to x is dy by dx. How do we find rate of change at a given value of x? At a given value of x, we construct a small interval around the given value of x. That small interval tends to 0. It's a very small interval. Technically speaking, it is called infinitesimally small interval when delta x tends to 0. When delta x is very small, when delta x tends to 0, it is called infinitesimally small. This is the technical term used. Infinitesimally small. So, in order to calculate the rate of change in y with respect to x at a given value of x, what we do is we construct an infinitesimally small interval around the given value of x. In that infinitesimally small interval around the given value of x, we calculate delta y by delta x. And that delta y by delta x tends to certain value. That delta y by delta x approaches certain value. As delta x approaches 0, delta y by delta x approaches certain value, and that value is called rate of change in y with respect to x at the given value of x. So we took some functions and calculated dy by dx. We also wrote down a formula. If y is equal to one of the basic formula of differentiation, if y is equal to x to the power of n, we wrote dy by dx is equal to n into x power n minus 1. This is the formula we derived in the last class. Also, we have seen some examples, some applications of this formula. Now let's move on to other functions. Let's move on to trigonometric functions. Well, before we move on to trigonometric functions, let's look at some applications of this differentiation in physics, basic mechanics. In mechanics, you can see that velocity is defined as rate of change in displacement with respect to time. Acceleration is defined as rate of change in velocity with respect to time. Rate of change means what? Rate means per unit. Velocity is rate of change in displacement with respect to time. It means this is displacement traveled by a body in a unit time. Acceleration is rate of change in velocity with respect to time. It means it is change in velocity in a unit time. Change in velocity in a unit time is called acceleration. Change in displacement in a unit time is called velocity. So these are velocities and accelerations at a given instant of time. What are these? This is velocity at a given instant of time. We also call this instantaneous velocity. This is acceleration at a given instant of time. Let's look at an example. Let us say let's look at one simple example and calculate velocity. Let's say a body is moving in a straight line. Displacement of a body moving in a straight line is varying with time according to this function, let us say. Displacement changes with time according to this function, s is equal to 3t square. Okay. Now, let's find out delta v by delta t in the interval, delta s by delta t. Let's find out delta s by delta t in the time interval t is equal to 0 to t is equal to 3 seconds. Also, let us find out ds by dt at t is equal to 0, t is equal to 1 second, and t is equal to 2 seconds. Maybe, and you can also find velocity at t is equal to 3 seconds. So we are going to find out delta s by delta t. Delta s by delta t is the rate of change in displacement with respect to time in this interval. ds by dt is rate of change in displacement with respect to time at given values of time. Okay. So how do you find out delta s by delta t? Let's look at the first question. Look at the first one. At t is equal to 0, because we are looking at the interval from t is equal to 0 to 3 seconds. At t is equal to 0, s is equal to 0. At t is equal to 3 seconds, s is equal to what? 3 into 3 square, 9 meters. 3 into 3 square is 27 meters. So in 3 seconds, the body has displaced by 27 meters. So you would write delta s by delta t is 27 minus 0, because displacement has changed from 0 to 27. So change is 27. The time interval is from 3 to 0. When you find you will get this 9 meters per second. This is the rate of change in displacement with respect to time in this given interval from 0 to 3 seconds. Let us find out. Let's find ds by dt. Let's answer the second question. Let's answer the second question. ds by dt. S is equal to 3t square. ds by dt is d by dt of 3t square. 3 is a constant, 3 doesn't change. So 3 into d by dt of t square. It's like this. Change in 3x is equal to 3 times change in x, or change in 3x square is equal to 3 times change in x square, or change in t square, 3t square is equal to 3 times change in t square. D is what? D indicates the change. Okay, change in 3t square is numerator, which can be written as 3 times change in t square. Okay, so that's what I did here. Now this is equal to 3 into d by dt of t square. We have this formula, d by dx of x power n is equal to, we derived this expression in the last class, n into x power n minus 1. Let's apply this formula. So you already have 3 here. When you apply that formula, you will get 2 into t power 2 minus 1. T into 2 into t power t minus 1. When you simplify, you will get ds by dt is equal to 6t. ds by dt is equal to 6t. That's what we are getting here. Now, at t is equal to 0, what is ds by dt equal to? Substitute t is equal to 0, you will get 0. At t is equal to 0. At t is equal to 1 second, velocity is how much? 6 meters per second. Substitute t is equal to 1 second. At t is equal to 2 seconds, velocity is 12 meters per second. Similarly, at t is equal to 3 seconds, velocity is 18 meters per second. So what is happening? Velocity means ds by dt. ds by dt is what? ds by dt is the rate of change in displacement at these given values of time. So rate of change in displacement at t is equal to 0, 0. And this rate of change in displacement at t is equal to 0 is called instantaneous velocity at t is equal to 0. Similarly, instantaneous velocity at t is equal to 1 second is 6 meters per second. Instantaneous velocity at 2 seconds is 12 meters per second. Instantaneous velocity at 3 seconds is 18 meters per second. At different instants, velocity or the rate of change in displacement with respect to time is different. But if you take the total interval 3 seconds, this is the rate of change in displacement with respect to time that you are getting. Okay, so what do these two indicate? This delta s by delta t is rate of change in the interval from 0 to 3 seconds. So this is an average rate of change. Why do we call it average rate of change in the given interval? Because in the given interval itself, at different points, the rate of change has different values. So in the given interval, this is total displacement by total time in the given interval. Since this is total change in s by total change in time, This is also called average rate of change in S with respect to t in the given interval. So this is average rate of change, or in this case you can call it average speed. In this case it is average velocity. And these are, what are these? These are instantaneous velocities. So ds by dt is what? Instantaneous rate of change. ds by dt is instantaneous rate of change, and delta s by delta t is average rate of change. So that's the difference between delta s by delta t and ds by dt. So you can say delta y by delta x in any given interval is total change in y divided by total change in x. So this is always average rate of change in any given interval, whereas dy by dx is instantaneous rate of change, that is rate of change at a particular value of x, at a given value of x. Okay. Now moving ahead, let us look at how to find dy by dx, how to find derivative in the case of trigonometric functions. Let's take trigonometric functions. In the case of trigonometric functions, let's try to understand how to find the derivative. Before we actually start discussing what is dy by dx if y is equal to sine x, what is dy by dx if y is equal to cos x, before we writing down this formula, let's try to understand what happens to sine x as x becomes infinitesimally small. As x tends to 0, what happens to sine x? As x tends to 0, what happens to cos x? Let's see these things first. Let's look at these two cases. As x tends to 0, as x becomes infinitesimally small, what happens to sine x and what happens to cos x? Let us discuss these two first, and then we will move on to how to write down the derivative of sine x and cos x. Okay, let's answer these questions. As x becomes very small means infinitesimally small. As x becomes infinitesimally small, sine x tends to x. As x approaches 0, sine x approaches x. How? And cos x approaches 1. Let's see how. For that, let's look at a circular arc. Let's draw a circular arc. First, let's draw two lines. Let's say angle between the two lines is x or theta. Let's say angle between these two lines is theta. Now draw a circular arc. The center with center at O. draw a circular arc with center at O. Look at the length of circular arc AB. Wait. To answer these questions, we will take two lines. And draw a circular arc by taking center at O. By taking center at O. Let's say these 2 points are A and B. AB, length of circular arc is, let's say, L. Radius is R. Radius is R. You know theta is equal to L by R. Look at the figure, you know theta is equal to length of the circular arc divided by radius of the circular arc. Let's draw a perpendicular from A to OB. If you draw a perpendicular from A to OB, let's say this point here is C. Now look at the right angled triangle OCA. Look at the right angled triangle OCA. In the right angled triangle OCA, sine theta is equal to opposite side. Let me call this Y, OC as X. OB of course is equal to radius of the circular arc. So sine theta is equal to Y by R and cos theta is equal to X by R. Look at the figure. Now as theta tends to 0, as theta becomes smaller and smaller, as theta becomes smaller and smaller, what happens to the value of Y? What happens to the value of Y? Draw one more right angled triangle with decreased angle theta. Now look at this point. Let me call this point D. Look at this angle. Angle has decreased. As you keep decreasing angle theta, this point is moving towards B. This point is moving towards B. Let me call this point E. Look at C. C was here, but D is now closer to B. Look at point E. Okay, Y value has decreased. When theta has decreased, Y value has decreased and X has increased. Okay, so as theta tends to 0, as theta becomes smaller and smaller, as theta tends to 0, look at Y and the length of the arc. Look at Y here and the length of the arc here. So look at Y and length of the arc. This is Y. when angle theta has decreased, y has decreased. Look at this arc length. As theta decreases, this vertical line length and arc length are coming closer to each other. In other words, y is tending towards L. I can say y is tending towards L. So as theta tends to 0, y and r become approximate, y and length of the arc become approximately equal. Okay, so this is the new length of the arc. When angle theta has decreased, look at the new right angle triangle, new arc. So new length of the arc and new vertical line length. The difference between y and L has decreased. Look at the original arc and original right angle triangle. So original y, look at this dotted line, this is the vertical line. Look at AB. AB is the original length of the arc, and the difference between y and L is originally more than the difference between y and L now. So in the second right angled triangle, if you look at second circular arc and second right angled triangle with decreased angle theta, when angle theta has decreased, y also has decreased, L also has decreased, and y and L, the difference between y and L has decreased. The difference between y and L keeps decreasing. We can say y approaches L. Y approaches L. And look at x. As theta decreases, this point C is moving towards B. So x value is originally OC. When you draw one more right angled triangle with decreased value theta, now the x value has increased from OC to OD. Look at x. Original in the initial right angled triangle, x is OC. But in the next right angled triangle with decreased angle theta that we have drawn, x is OD. So what is happening to this point C? This point C is moving towards B. In other words, x is tending towards R. So from the figure it is clear that as theta tends to 0, the opposite side length tends to length of the arc and adjacent side length tends to radius of the arc. So y approaches L, x approaches R. So as theta tends to 0, y approaches L and x approaches R. Okay, I'll put this in the following way. As theta tends to 0, sine theta is equal to y by R approaches, I'll write it in words, approaches L by R, because y approaches L means y by R approaches L by R. What is L by R equal to? Theta. So in other words, we can write as theta tends to 0, sine theta approaches theta. The value of sine theta is close to theta. Similarly, cos theta, look at cos theta. X tends to R, so cos theta is equal to x by R approaches R by R, which is 1. So cos theta is equal to x by R approaches 1. As theta tends to 0, cos theta approaches 1 and sin theta approaches theta. That's the conclusion. So I am going to write here these two conclusions. As theta tends to 0, as theta approaches 0, I am not saying theta is equal to 0. Please understand the difference. Theta tends to 0 means theta becomes infinitesimally small but not equal to 0. As theta tends to 0, sin theta approaches theta and cos theta value approaches 1. We can write it in the technical language, in the mathematical language. If we write limit theta tends to 0, sin theta is equal to theta. Limit theta tends to 0, cos theta is equal to 1. I don't know if mathematics teachers approve this way of explaining things. But if I have to look at things, this is how I understand. As theta tends to 0, sin theta approaches theta, and as theta tends to 0, cos theta approaches 1. You can also understand these things from the graph, sin theta graph. Okay, let's look at sin theta graph and cos theta graph. Let's draw sin theta and cos theta graphs. In trigonometry class, we discussed these things. In trigonometry class, we discussed how to draw graph between theta and sin theta. We know how to draw graph between theta and sin theta. The graph between theta and sin theta comes like this. Okay. So look at the values close to 0. Zoom this graph in. Zoom into this graph and zoom in this graph and check the graph now. For very small values of theta, sin theta is approximately theta. This angle is approximately 45 degrees. This angle is approximately 45 degrees means what? Sin theta is equal to theta. Okay, look at sin theta versus theta graph and understand how sin theta is changing as angle theta is changing for small values of theta. So at small values of theta, sin theta is approximately equal to theta. Similarly, you can also draw cos theta graph. Similarly, you can also draw cos theta graph. This is how the cos theta graph will be. Okay, for values close to 0, cos theta is approximately equal to 1. For values close to 0, cos theta is equal to approximately 1. In calculator also you can do this. Find out sine 1 degree value. Find out sine 2 degrees value. You will get sine 1 degree value approximately equal to pi by 180. Because 1 degree is equal to how many radians? Pi by 180. You will get sine 1 degree is also equal to pi by 180. Sine 2 degree value if you find, you will get its value close to 2 pi by 180. Let's ask calculator what sine 1 degrees is equal to. Sine 1 degree is equal to 0.0174524064. This is what calculator says. Let's find out 1 degree is equal to how many radians? 1 degree is equal to pi by 180. That is 3.14 divided by 180. If I calculate 3.14 divided by 180, I am getting 1 degree is equal to, I am getting 0.0174444. So look at how close are these numbers. There is no significant difference between these two numbers. After decimal point, 4 digits are same. So you can say that sine 1 degree is equal to pi by 180. Sine 1 degree is equal to the value of 1 degree, which is pi by 180. Sine 2 degrees is equal to 2 pi by 180. So for small values of theta, you can take the approximation that sine theta is equal to theta. For small values of theta, that is, we already have written in the previous page. For small values of theta, sine theta is approximately equal to theta and cos theta is approximately equal to 1. Now let us look at how to find the derivative of sine theta or sine x, and how to find the derivative of cos theta or cos x. If y is equal to sine x, how to find dy by dx? You can write, if y changes by a small amount, that's because x changes by a small amount. Let's say x changes from x to x plus dx. Y changes to y plus dy. So if x changes to x plus dx and y changes to y plus dy, you can write down this relation. Y plus dy is equal to sine x plus dx. Now apply sine alpha plus beta formula we discussed in the class before, or sine a plus b formula. This is sine x into cos dx sin x into cos dx plus cos x into sin dx. This is y plus dy equal to. Since dx is very small, since dx is infinitesimally small, since dx tends to 0, as we discussed just now, sin dx tends to what? Dx. Sin dx tends to dx, as dx tends to 0. And cos dx tends to what? 1. So you can use the approximation that cos dx is equal to 1 and sin dx is equal to dx in this equation. Okay, so in this equation I am going to replace cos dx with 1 and sin dx with dx. So I will write down this equation as the following. I will write y plus dy is equal to sin x into cos dx is equal to what? 1 plus cos x into sin dx is equal to what? Dx. So this equation is y plus dy is equal to sin x plus cos x into dx. So simplify this. Y is equal to sin x. So y and sin x get cancelled on both these sides. So you can write this equation as dy is equal to cos x into dx. Or you can write it as dy by dx is equal to cos x. So when y is equal to sin x, its derivative, that is d by dx of sin x, d sin x by dx, or d by dx of sin x is equal to cos x. Derivative of sin x is equal to cos x. Rate of change in sin x with respect to x is equal to cos x. This is how we can find derivative of sin x. We can also find the derivative of cos x in the similar way. Okay, let's see how. Let's take now y is equal to cos x and find its derivative. To find its derivative, we write y plus dy is equal to cos x plus dx. When x changes to x plus dx, y changes to y plus dy. Expand this. On the right hand side, use cos a plus b formula and expand. You will get cos x into cos dx minus sin x into sin dx. As you know, since dx is infinitesimally small, cos dx is approximately equal to 1 and sin dx is approximately equal to dx. I am going to use this approximation to rewrite this equation as the following: y plus dy is equal to cos x, cos dx is 1 minus sin x into sin dx is equal to dx, approximately equal to dx. You know, y and cos x cancel out. You will have dy is equal to minus sin x into dx. So take dx to the left hand side of the equation. You will have dy by dx is equal to minus sin x. This is how we find the derivative of cos x. You can also write dy by dx of cos x is equal to minus sin x. Rate of change in cos x with respect to x is equal to minus sin x. To find derivatives of other trigonometric functions, we can use rules of differentiation: addition rule, multiplication rule, division rule. Okay, for example, to find the derivative of tan x, you can assume that you know that tan x is equal to sin x by cos x. Sin x in the numerator, cos x in the denominator. We can use division rule there. We will discuss what division rule is. Similarly, to find derivative of cosecant x, you can again use division rule. Cosecant x is equal to 1 by sin x. So to find derivatives of other trigonometric functions, you can use multiplication rule and division rule in differentiation. What are those rules? What are addition rule, multiplication rule and division rule in differentiation? We will discuss now.